In this video, we're going to learn how to solve radical equations. Now, a radical equation is any equation that has a radical, a square root, cube root, and so on in it. Most of the time, we're going to be dealing with square roots, but occasionally we'll have cube roots and something else involved that we have to deal with. So let's go ahead and look at the process for this. So the first one, we have square root of 2x minus 5 equal to 3. Well, we've learned that when you have an equation, you can always do something to both sides as long as you do the same thing to both sides. And that includes squaring them. So I'm going to go ahead and square both sides of this equation. And the reason we do that is because if you square something that's got a square root, right, the square root of 2x minus 5 squared, that's going to give you just back to 2x minus 5. It's one of the properties of square roots. Well, then we can go ahead and add 5 to both sides, and then divide by 2, and we get x equal to 7. I do want to give you a warning at this point. When we are solving radical equations, specifically things with square root or other even roots, the method that we are using is flawed. And what that means is that sometimes you're going to do everything right, but at the end of the day, the number that you get here will not actually work in the original equation. Those are called extraneous solutions. And so what that means is anytime you're solving a radical equation, you really need to check your answer to make sure that it actually works out correctly. Otherwise, you need to cross it out and it's not a valid answer. Now for this one, if I go ahead and do that, 2 times 7 minus 5 equal to 3. 14 minus 5, square root of 9. And square root of 9 is in fact 3, so this is a perfectly valid solution. But it is definitely something you want to be worrying about and trying as you're solving these problems. Now you might say, why am I teaching you a method that's flawed like this? Why don't I give you the perfect method so you don't have to worry about this? Well, as far as I know, there is no perfect method other than trying your final answer here. So it's just something we kind of have to deal with. Now in this next problem, we have square root of x plus 4 plus 3 equal to 1. If you try to square both sides at the start, it is not going to be good. Because when I try to square this whole thing here with these two parts, that's really like square root of x plus 4 plus 3 times square root of x plus 4 plus 3. And then you have to FOIL that. It doesn't just kill the square root by easy. You have to FOIL that. And when you do the first, you're going to get the x plus 4. And then the outer would be 3 square root of x plus 4. And the inner is another 3 square root of x plus 4. And the last is 9. And the thing that's really important here is we squared it, and it didn't get rid of the square root. We still have the same square root we started with. That's why this is not what you want to do here. Instead, you want to try to get the square root all by itself. So I can do that by subtracting 3. And 1 minus 3 is negative 2. Then I can go ahead, once the square root is by itself and I square both sides, then the square root does go away right away here. And negative 2 squared is 4. And then we subtract 4, we get x equal to 0. However, if you try this one, here, this is going to be false. This would be 2 plus 3 equal to 1. It's not going to work. Which means x equal to 0 is not a good solution. And since there was nothing else, that means there is no solution to this problem. It's possible we could have noticed that without doing all this work. Once we did the first step and saw that the square root of x plus 4 equals negative 2, once you get there, you can actually go straight to saying there's no solution, because we know that the square root of any number will never give you a negative answer. So right away, you know there's not going to be any possible answer to the problem. The reason why I worked it all out here is to show you that even if you don't notice that, if you just follow through the steps and check your answer, it'll still work out just fine. Now we look at part C here. This one's the only one with a cube root in it. In fact, it looks suspiciously similar to the previous one. The main difference here is that after I subtract 3, we don't care about there being a negative when you have a cube root. Only square roots have or other even roots have problems with negatives. Cube roots do not. So when I go ahead and cube both sides, cube root cubed is x plus 4, negative 2 cubed is negative 8, and then subtract 4, and we get our answer. Of course, you should check that, and you'll see it works. Of course, in cube root equations, it's going to work. It's just the even roots that are a problem. And in case you're wondering why even roots are a problem and odd roots are not, it's because of the following fact here. If I take negative 2 and square it, I get 4, and that's the same answer as positive 2 and squaring it. And so what that means is if I get to a 4 somewhere, I don't know if it came from a positive or negative 2. That's basically the same thing as something we'll see later on what are called inverse functions, that you don't know where you came from, you can't go back and solve the problem. Whereas when you have an odd power and you cube it, so in this case cube here, you are going to get positive 8 or negative 8, and then you're going to know which one came from which. If you get a positive answer, you came from a positive number, and if you get a negative answer, you came from a negative number. So you know what's happening there. Regardless, it's a good habit to check your answer on every problem, even if the cube roots aren't really required for that. Now, on part D here, I made it a little bit harder because I threw in an extra variable on the right-hand side here. We do have the square root by itself at the start, so I can go ahead and square both sides. I do need to be careful, though, that when I'm squaring the right side, I'm going to have to write that out and FOIL it there. All right, this is the same as x plus 1 times x plus 1. And then when you FOIL it out, you're going to get x squared plus 2x plus 1. Then we're going to go ahead and, since this is a quadratic equation, we're going to get everything on one side. 0 is x squared minus x minus 6. That factors nicely into x minus 3, x plus 2. So we get two answers here, 3 and negative 2. However, if you plug in the 3, it will work fine. But if you plug in the negative 2, it's not going to work out. And definitely take the time and check that yourself to see that it doesn't work. And it's not just the fact that the x is a negative number. You can have negative answers, but if you plug in negative 2, it is not going to work out in that problem. Okay, now there's one last one here, which is the hardest of all of them. It's because we have two separate square roots in the problem. Whenever you have two separate square roots in the problem, you are going to eventually have to square both sides twice in order to get rid of both square roots. But before you can even do it the first time, you have to isolate one of the square roots. So I'm choosing to add the square root of x plus 3 to the other side so that I get the square root of 3x plus 6 alone. Then I will square both sides. When I square the left side, square root squared gets 3x plus 6. On the right side, I have to FOIL that out, and it's a big mess. And the first would be 1 times 1, and the outer would be 1 times square root of x plus 3, and the inner would be 1 times square root of x plus 3, and the last would be square root of x plus 3 times square root of x plus 3, which is x plus 3. Then I want to get the square root by itself, so I'm going to start moving everything else to the other side. This would give me a 2x plus 2. And the right side, I can combine those to make 2 times square root of x plus 3. Now, when you're doing these problems, you're always going to have some sort of a coefficient in front of the square root. And you can choose to either divide by it or leave it there and square both sides. For myself, I usually ask, could I divide by it and not have fractions? Or if I divide by it, would I have fractions? And that's how I decide what to do. So for example, in this case, if I divide by 2, 2 divides evenly everywhere nicely, and I have no fractions there. So I'm going to choose to do that. But if I had had like a 5 there instead, when you divide by 5, it's not going to divide evenly. You're going to have fractions, and then you have to deal with fractions when you FOIL out the next step. So, which is kind of a pain. So personally, just check whether you can divide and not have fractions, and if so, you should divide. Otherwise, kind of leave it alone. Once you've gotten the second square root by itself, you will square both sides again. Go ahead and FOIL there, x squared plus 2x plus 1. And the square root of x plus 3 squared is x plus 3. Go ahead and subtract my x, subtract my 3. X squared plus x minus 2. I can go ahead and factor this. I get negative 2 and positive 1. And then you have to check whether those things work. Negative 2 would not work. Positive 1 would work. Again, you really need to take the time to check them for yourselves here. And so the only answer to this problem would be x equal to 1.